So, okay, another operation that we can do with vectors is multiplication by a scalar. So, what that is basically you're going to take a vector and then you're going to multiply by a scalar, say 2, and then what you get is a vector that has the same direction but is twice as long. So, a multiplication by a scalar changes the length of the vector. It may stretch the vector, it may shrink the vector, even change directions. So that's what the multiplication do. If we multiply by 0, then we get a vector that has 0 length. So a vector cannot have negative magnitudes. The magnitude is just basically how long the vector is. That cannot be a negative number. So if we multiply a vector by a negative number, what we actually get is we reverse the direction. For instance, we have here the vector A, and if we multiply A by -1, what we're going to get is the vector minus A. So A plus minus A has this neat property that gives you 0. So here is a vector A, and then we multiply the vector by 2, and we're going to get a vector that is twice as long in the same direction. If we multiply the vector by -3, we are going to get a vector that is 3 times as long, but now it points in the opposite direction because of the minus sign. Let's review a little bit of addition here. So we have two vectors A and B. So what is the addition vector here? Okay, so we can apply our parallelogram rule or the tip to tail, whichever you choose. So you have this parallelogram, and this is your vector addition, which would be closer to this one here. Okay, so let's go on to vector subtraction. So vector subtraction is basically this, right? So if you have two vectors, A plus A minus B, you want to do that, A minus B. So what this is actually A plus minus B. So what you're doing is adding to A the vector that is multiplied by -1. For instance, here's a vector A, here's a vector B. So then A plus minus B is equal to this picture that you have here. This is A, and this is a vector B multiplied by -1. So then your subtraction is this vector that goes from here to here. So another question here, you have vectors P and Q. What is a vector P minus Q? Take a minute to answer this question. Okay, so let's do this slowly. So we want the vector P minus Q, right? So we want the vector P minus Q. So that vector is equal to P plus minus Q. So let's draw this. So this is vector P, right? And this is the vector Q. So but what we want is P plus minus, sorry, this is the, let's start over. I made a mistake there. So this is the vector P, and this here is the vector Q. So this is P, and this is Q. So now this vector here, that's the vector minus Q, right? So this is minus Q, and that's what you want to add. So P plus minus Q give you this vector that goes all the way here, right? If you apply the parallelogram rule. So it'll be this guy here, and that's how you do that. All right, so one more question. Which of the vectors in the second row shows that 2A minus B, or shows the vector 2A minus B? Take a minute to answer this question. All right, so let's do this slowly. So 2A is a vector that is twice as long in the same direction, right? So something like this. B is a vector that, minus B is a vector that it is in this direction, right? Opposite direction, that is B. So this is 2A and this is B. So now the vector addition of these two, which is 2a minus b, remember 2a minus b is equal to 2a plus minus b, right? So then is this vector here, so we can do the parallelogram rule here, and this is the vector addition there, and that will be this guy here. All right. Thank you.